13 Key factors about classical mechanics. 1. Newton's three laws of motion. Classical mechanics is fundamentally based on Newton's three laws of motion. An object remains at rest or in uniform motion unless acted upon by a force, inertia. Force equals mass times acceleration, F equals ma. For every action, there is an equal and opposite reaction. 2. The law of universal gravitation. Newton's law of universal gravitation describes the gravitational force between two masses as proportional to their masses and inversely proportional to the square of the distance between them. 3. Conservation of energy. In classical mechanics, energy is conserved in a closed system. The total energy, including kinetic and potential energy, remains constant over time. 4. Conservation of momentum. Momentum, the product of an object's mass and velocity, is conserved in a system with no external forces, meaning the total momentum before and after an event remains the same. 5. Kinematics versus dynamics. Kinematics deals with the description of motion, position, velocity, acceleration, without considering the causes, while dynamics considers the forces and torques that cause motion. 6. The principle of inertia. This principle states that an object will maintain its state of rest or uniform motion unless acted upon by a net external force, reflecting the concept of inertia. 7. Work-energy theorem. The work done on an object by a force is equal to the change in its kinetic energy, linking the concepts of force, displacement, and energy. 8. Rigid body motion. Classical mechanics also deals with the motion of rigid bodies, where all parts of the object move in a fixed relation to each other, including rotational motion around a fixed axis. 9. Simple harmonic motion. This type of periodic motion occurs when the restoring force on an object is directly proportional to its displacement, such as in the case of a mass on a spring or a pendulum. 10. Projectile motion. Classical mechanics explains projectile motion as the trajectory of an object under the influence of gravity, following a parabolic path, assuming no air resistance. 11. Circular motion. Objects in circular motion experience a centripetal force that keeps them moving in a circular path. This force is always directed towards the center of the circle. 12. Rotational dynamics. The study of rotational dynamics in classical mechanics involves concepts like torque, angular momentum, and the moment of inertia, which describe the rotational motion of objects. 13. Classical mechanics and relativity. Classical mechanics is applicable at low velocities compared to the speed of light. However, it breaks down when dealing with very high speeds or strong gravitational fields, where Einstein's theory of relativity provides a more accurate description. These facts outline the foundational principles and concepts of classical mechanics, which describe the motion of macroscopic objects and remain essential in understanding the physical world in everyday contexts. Thank you for watching. Like, comment, share and subscribe for more.